Good morning, guys. Today I am going to explain about one of the scenario based question. Which of the optimization technique discussed do you think which would have most impact on the performance of large scale applications and why? Or they can state like that. You can describe a situation from your experience where the optimization a query significantly improved the performance. I am going to talk about something which is crucial for working with the large data sets or databases. Optimization query performance. In the simple terms, like query is about making sure our database operations are fast and efficient as possible. This is vital because slow queries can lead to the delay and increase the cost and a a poor user experience. Like optimization query performance is a crucial aspect of data engineering, and especially when you deal with the large databases, pure optimization queries can lead to the slow performance, increase the cost, insufficiency in data process, and there are more data detailed explanation with the examples of illustrate showing the key concepts. Some of the key concepts we are going to discuss here, like indexing and query execution plan and partition and denormalization and materialized views and caching. Indexing is the first main thing we are dealing with the to improve the performance. Indexing are the database structures that improve the speed of the data retrieving operations on the database table. Indexing works like a table of concepts content in the book allows us the database engine to quickly find the row in it need without scanning the entire table. Like thinking like think of an index like book of table of contents. Instead of flipping through every page to find what you are looking for, you can start jumping to the right section. And similarly in the database, on an index helps us to quickly locate the data where we need without scanning the entire table. For instance, if we frequently search for the employee employee last name, and creating an index on employee last name column can make those searches much more faster. For example, take select star from the employment where last name is equal to Smith. Without indexing, it's going to scan the whole table and each row to find where the last name is Smith. This can be very slow because especially as the table grows, it's going to be quite complex for the processing the entire table and searching for the where is the name is Smith. You can optimize by creating an index on the last name column. By creating an index on the employee last name, now the table now the retrieved data is going to be much more faster. There you can see a significant speed up in the data query. And query execution plans is a is like a roadmap that database engine follows to execute. It shows how the database will retrieve the data, including which index may be used and the order of operations are more. we have the indexing execution planning. By analyzing the indexing execution planning, we can see how the data processor query identify any bottleneck. If we find that, say, query is doing a full scan without insignificant joins, we can make a adjustment like adding an index or something like rewriting the query to improve the performance. For example, we can take, let us see how the query joins two large tables. Select star employee table from E and join the table on the department where the analyzing the execution plan. You can use a tool called explain in the MySQL to retrieve the data, and by using the explain keyword can easily identify what's the execution plan where we can use. Next we are going to move on partitioning. Partitioning is another more powerful. Let's splitting the large data into smaller and more manageable chunks. When we partition a table, we divide it on key like, for example, take date or region, so the query can focus on just the relevant part of the data. This reduces the amount of data that database needs to scan, makes the query faster. For instance, if the clients are only interested in the sales data from 2023, we can partition our data by key and allow the database to skip all the irrelevant data from other years. Like suppose we have like sales table with multiple years, we can frequently take only the relevant data. We can create the table with the sales name. We can add partition by range. We can select the range and we can partition by the year like 2022 and like 2023 and like 2000. Now the query of the sales in 2023, it's only speed up the by using the partition. The query is much more faster than the previous execution. And next we are going to move on the denormalization part. Denormalization involves adding the relevant redundant data and combine the table to reduce the complexity of the queries. While it might increase the storage space, it can significantly speed up the query by avoiding the complex joins. For example, if we frequently join on orders tables with the customer table, to get the customer name, we should store the customer name directly into the orders table. This way we can eliminate the need for the joins, and which may help for the making the query more faster. For example, take orders skill and customer skill. To optimize, we denormalize by adding the customer's name directly into the orders table. Now we can avoid the join and we can run, which overall the improvement of the speed is going to be drastically improved because we remove the join operation in the between them. And next we are going to discuss about materialized views are pre-computed and stored results of complex queries. Instead of running the query from the scratch every time, we can query the materialistic views, which is more faster. Imagine you only need to see the total sales per day department. By creating the materialistic view that stores this information, we can access it without reprocessing the data. Finally, let us talk about caching. Finally, caching stores the result of frequently accessed query in the memory, so they can retrieve the quickly without hitting the database every time. For example, if our frequently displaying the top 10 best selling products, we can store this list in a cache and refresh it periodically. This reduces the load on our database and speeds up the response time. Instead of going every time to retrieve the top 10, you can gradually increase our speed and this reduce the load on the database. Optimizing query performance is all about using the right tools and techniques to make our database operations more effective. By using the indexing and analyzing the execution plan and partitioning the data and denormalizing the table, utilizing the materialist views and implementing caching could ensure that our queries are faster and our system is responsible. This not only improve the performance but also enhance the overall user experience. Thank you.